Hello everyone, welcome back to Ampnics. In this video, we are going to discuss something really exciting. Nowadays, everyone is using AI tools for their daily life tasks. Being an electronics engineer, I wonder, can we utilize these AI tools for designing the hardware or writing the firmware or developing a complete product? So, the answer is not pretty straightforward. In last two videos, we already designed two PCBs with the help of Grok AI and DeepSeek. But this time we are going to design an industry level project with the help of ChatGPT. In this video, we are going to ask a lot of questions with the ChatGPT, and as we know, ChatGPT cannot design the schematic or layout directly, but we will take the help of ChatGPT while designing the complete PCB. So let's get started. The user interface of ChatGPT is quite simple and we can start asking our question here. So I already written all the question in my notepad so that we cannot exceed the video too long. Okay, so here's my question. I want to design a hardware circuit that uses RS485 communication to control external 12 volts loads. Each load channel should be able to switch up to peak 3 ampere continuous current. The system should be microcontroller based and robust for industrial application. Can you help me define the basic functional block? In this prompt, we are just giving a generalized idea about our project, that is going to be a switching circuit over RS485. Our input voltage is about 12 volt and the peak current is about 3 ampere. Let's see. Here's the response of ChatGPT on our prompt. Absolutely, for a robust microcontroller based industrial control system using RS485 to switch 12 volt load up to 3 ampere continuous current, here's the key functional block that you should include in your hardware design. Number one, power supply. So power supply is basically responsible for providing the energy in the every block of our project. So yes, this block is important. Then we have microcontroller, and in industrial grade microcontrollers such as STM32 at mega ESP32 or peak, like it is considering the majority stakeholder of the embedded world such as STM at mega or ESP boards. Okay, so as of now, this is like very general question, so we will just consider it as general question only, although suggestion is good. Then for RS485 communication interface, yeah, this suggestion is literally amazing. I mean, it is giving us exact devices such as like SN75176 Max 485, ISO 1410. So a lot of time I already worked with these ICs. These are great for RS485 communication. Okay, then for load switching block, so we can consider n-channel MOSFET or smart high side switches such as BTS 5000 XX series or gate driver if MOSFET is used for ensure fast and reliable switching. Yes, we can utilize that also. And if you are confusing at this point, so do not take a lot of load. I will explain you in the schematic design. As of now, just consider that it is considering as a fourth block, which is a switching circuit. And then for protection and diagnostic block, well, we are going to already consider these as of hardware wise, we are going to consider these four blocks. Let's ask for block diagram, actual block diagram. So here's the text based block diagram of our project. We have power input which is 12 volt, then power supply block. Okay, why two power supplies? Basically our main power supply is about 12 volt, and then we are converting that 12 volt into 5 volt or 3.3 volt. Basically it is considering that if you use STM32 or ESP32, so at that time we will need 3.3 volt, or if we use peak controllers or at mega 328p controllers, then at that time we use 5 volt. So basically it is considering both of them, which is 100% correct. Then for microcontroller we have another block for RS485. So main power supply, then power supply block, microcontroller RS485. and then we have our switching circuit. So when we get the command on RS485, that command will forward the data to the switching circuit. Basically it will turn on the MOSFET or relay, so it is forwarding the data from RS485 to controller, and that controller will switch the switching device. And further we have protection devices. So this block diagram is completely fine, we can refer this one, but it will be more suitable or more visualizing when we decide the exact component for our project. All right, so now we will go for component selection, and I will give a prompt here, and I will also give some hint for designing or selecting the component so that it can give us the proper device selection of our project. Let's see. So we got the response of selected device on the basis of our prompt, and here's a keynote that you have to note at this point. Like I given hint also, like for RS485 transceiver IC we have given a hint SN75176, and for microcontroller we have given a hint like we are going to use STM32 F103. Okay, so these are two hints that we given to this prompt. Let's check out the devices. So number one, n channel MOSFET for 12 volt up to 3 ampere peak. So what you need, basically it is talking about every technical detail which is required for designing this project. I'm not gonna talk in detail. What I will do, I will share this chat in the description, you can read it by yourself also. But I'm interested in the selected devices. So it is saying that we can utilize or use IRLZ44N. Well, this MOSFET is ideal choice for switching from 3.3 volts, so this is good, and we are going to use this device only. Or if you are confusing and if you are someone who don't know about these devices, what you can do, you can copy this device name and you can read the data sheet of it. Okay, so that will give you more confidence. Then for flyback diode or freewheel diode, it is suggesting us to use STPS 3L60, which is having the protection up to 60 volt 3 ampere, and it is a Schottky diode, which means the response of this diode is going to be fast. Okay, and the alternate of this diode is 1N5822. It is also cost effective and available. So for freewheel diode or flyback diode we have two options, either we can go with STPS 1 or we can go with 1N5822. And third one, RS485 transceiver IC. So you hinted SN75176. On the basis of this, I guess it is suggesting us to use Texas Instruments THVD 1450. I guess this is like a very popular RS485 transceiver IC. It has up to 15 kV ESD protection, which is good choice for industrial application. And the alternate of this IC is SN75HD75, or we can also use this ISO 14 or 10. So at this point, like I'm gonna use this only. I'm interested in this one because I already designed few products. So if you design more and more PCBs, you will get the confidence also. So if you are someone who always have doubts like either my PCB will work or not, what you can do, you can refer some previous developers project and you can build some confidence in yourself. Okay, then for power supply we have a buck converter, which is good choice, like it is suggesting us to use a DC converter. Otherwise if it says like use linear converter or something like 7805 or 7812, that is not good approach. So it is saying us to use LM2596 5 volt fix 5 volt. Okay, this is a great suggestion, we can use this one. And then for LDO, what is saying, we can use MCP1700T, or the alternate of this one we have AMS 1117, very popular LDO. And then for microcontroller we already given the suggestion for it, and we are going to use this blue pill microcontroller. I guess the selection of devices is quite fine, but still I will say that you cannot rely on any AI tool for selecting the component, because selecting a component determines your project's budget, so you have to take care of that also. So as for your budget you have to design, and if you or specifically you have to convey something, then you can write it in your prompt also that your budget is something related to this or that. So this video is for educating, for that reason I'm not including those points. All right, but you can use it, you can experiment it with yourself. All right, so we have our schematic design here, and as you can see we have differentiated the schematic into the blocks on the basis of their functionality. All right, so we have power supply, loads, RS485 port, STM32, and mounting hole. So we will begin it from power supply. And if you're someone who struggles to design the schematic or to design the layout in KiCad, so I have a good news for you. You can follow this playlist how to KiCad. Basically in this playlist I have explained everything which you required for designing a PCB in KiCad. So for power supply we referred LM2596 fixed 5 volt and AMS 111 3.3 volt. All right, so we have this buck converter for converting 12 volt into 5 volt, and then further this 5 volt is converting into 3.3 volt. All right, so this unit is basically responsible for providing the energy into every block of our PCB. Okay, then further we have load circuit. So for switching the load we have utilized the MOSFET, and do not worry about this schematic, you can download it directly from my GitHub. All right, so you don't have to worry about that. So we have this switching device which is n channel MOSFET IRLZ44N. So we utilize it for switching the load. And if I talk about the protection, so instead of the given diodes we have used SS34 Schottky diode. It is also having the same configuration almost, so we can use this also. Why I used this one? Because it is very popular and easy to find in the market, so for that reason I have included it. Further we have some resistor and capacitor for smoothing the current, and here we have pull down and limiting the current. Okay, so we have resistor and capacitor also. So this is our switching block. Basically this is responsible for switching. Okay, then further we have RS485 port, and as you can see I already mentioned some comments in the block also, so you can refer that also. All right, so in RS485 we have used SN75176AD. So it will took the data from here, like from A and B, and this is connected to our microcontroller. So this transceiver IC is responsible for communicating via RS485. Okay, along with that we have added to debug LED also, so we can visualize it like data is transferring from these pins or not. All right, then further we have our main brain of our project, which is STM32 F103. This is the block which is responsible for processing all the units. Okay, so we have this connectors for programming the microcontroller. We have reset button, we have a debugging LED, then we have some decoupling capacitor. All right, we have a crystal here which is required for this microcontroller. Okay, so these are the bare minimum blocks, and I guess it is very simple. You can do it by yourself. It is very easy. Although if you see, like 90% of the devices is same as which was suggested by the ChatGPT. Now we will review our schematic with the help of ChatGPT. So here's my prompt. I have designed a schematic for RS485 load switching circuit using your block diagram as reference. Can you help me review the schematic and check all the required decoupling capacitors are present, proper communication and logic levels are used, Load switching design is safe and protected. Power supply rails are well managed. Any important component might be missing. And we will also add our PDF here, okay, PDF of our schematic so that it can answer us in better way. Here's the review of our schematic that decoupling capacitors present and sufficient, or like decoupling capacitors are available in sufficient amount, like for MCU and for AMS1117, for RS485, okay, like this is good practice overall. You may consider one more zero point 0.1 cap close to each power pin if allows space, but you are mostly correct. Okay, are all the components, especially the decoupling capacitors, are correct. It is suggesting us somewhere to use more zero point 0.1 microfarad capacitor, although already I used everywhere, so I don't think so we need to add more into it. Okay, then for logic level L communication, correct and safe. Okay, and STM32 runs on 3.3 volt fed from, yes, we are feeding it from AMS 1117, 3.3 volt. Okay, suggestion, if this were scale or go into industrial production, you might want to use 3.3 volt for RS485 transceiver like THVD 1450 to eliminate mixed voltage domain issue. Okay, so basically it is saying that if you are going to use it in industrial production, better use THVD for 1450, because it is going to be perform better than this one, because this works on 5 volt and this THVD works on 3.3 volt. So as of now we already have 5 volt also on our board, so we can use this only. You can also give a try to it. Okay, then for load and switching circuit, MOSFET switching design is correct, like it is perfectly loaded. What are the suggestions? Gate resistors, so it is saying us that 100 E are not clearly seen, so consider adding one in series of each MOSFET gate to dampen the ringing. Okay, this is really important to avoid ringing. We should add 100 ohm resistor, but I guess we already added it here, which is about 1 kilo ohms, and add a pull down resistor about 10k. We already added a pull down 10 kilo ohm resistor. So as you can see, like somewhere ChatGPT lacks also, so you have to use your own mind also, or I can say like you have to use your own brain also. After designing the schematic, you have to make sure to confirm it or review it from 2-3 sources. Okay, and if you don't have any resource, or if you don't have any connection to verify your schematics, you can join my community chat over WhatsApp. The link is in the description, where we used to discuss about such technical stuffs. Okay, then for power supply, well managed. Okay, good filtering, buck converter is properly filter, enter buck caps. Suggestion, consider thermal dissipation for AMS 1117, especially if drawing the significant current from it. Possibly upgrade to low dropout high efficiency LDO like MIC 5219. So like we are not going to draw a lot of current from AMS 1117, so in this case it is fine. We don't need to go for MIC 5219. Every time you will find that AI tools make a small issue into bigger picture, so you have to take care of that also. Like AMS 1117 can handle easily up to 1 ampere, so that is more than sufficient. What are the potential missing or optional improvement? So this is optional, so we will ignore it. Like we can if we can see like everything is all right, so as of now I'm not interested in it. Now we will go for the layout design, and before going on the layout design, we are going to ask to ChatGPT for determining the trace width of the signal and power rails. So here's my prompt. Now I'm moving to PCB layout in KiCad. Can you give me detailed guidance on choosing the correct width of for 1 ampere and 3 ampere peak on each channel, on a two layer board. Best layout practice for RS485 differential pair termination and isolation. Placement tips for capacitors, diode and switching devices. Keeping a power and signal paths clean and noise free. Thermal management and grounding strategies. Okay, so let's go. Number one, trace width for 1 ampere continuous or 3 ampere peak current. So we can utilize up to 1.3 to 1.5 of track, and it is like a good approach for 3 ampere, up to 3 ampere. Okay, and it is also suggesting us like you can follow the IPC 2221 based tools, example Saturn PCB toolkit. So if you don't know what is this Saturn PCB toolkit, make sure to give a try to it. It's a wonderful tool for determining the antenna or width or trace width. It's a good tool for PCB designing, and if you need a tutorial on it, make sure to do the comment. I will bring some tutorial on it also. Okay, then for RS485, keep the A and B traces tightly coupled and equal length within few and it is like you should keep it about 6 into 6 by 6 or 8 by 8 mils. Okay, this is good, and make sure to add 120 ohm resistor, which we already added it. And isolation, if galvanic isolation is needed, use digital isolators such as ISO 1410 or isolated DC-DC converter. So basically, instead of using LM2596, we can go for the isolated DC supply, such as like a lot of other brands like XP Power. You can find the XP Power family for isolated supplies. Okay, so this is also a suggestion for, and it is optional. Okay, then for placement tips, decoupling capacitor as close as physically possible to the IC power pins. Exactly, but we have to take care of DFM also. So when I will show you the 3D model of the PCB, at that time I will explain you why it is important not to put it very much close to the ICs. Okay, then for diode, place the across to the load. Okay, this is good. Switching devices, keep the MOSFET, diode and the load connected tightly grouped. Okay, that's good. Then clean signal and power separation. Layout zones, split high current path MOSFET loads and Vin from the low level signal. Yeah, that's true. Like we have to keep apart these signals from the other signals. Use island separate copper pore for load ground power and signal power for MCU. Yes, we are going to follow this only. Route signal traces under inductors, we have to avoid it. Switching regulators or high current paths. Long traces like MCU, GPU to MOSFET gate minimize EMI pickup. Okay, then thermal consideration, grounding strategy, and use single ground connection between power ground and logic ground if possible. So at this point it may be possible that you cannot get everything. Okay, when I will show you the layout, at that time you will visualize it better. Okay, copper flood the top and bottom layer with the ground wherever possible. Improve the thermal and EMI performance. So basically it will improve the thermal and EMI performance if we follow this. Okay, layout design of our board. As you can see, this is our top layer, and this is our load ground, which are separated in both of MOSFET. And here we have our buck converter. This is our buck converter section, or you can say power supply. And apart from that, like you can see here, we have A and B signal which is connected to our transceiver. And one thing you have to notice that these all parts are not poured with the copper. Why so? Because I want to avoid EMI and EMC interference. For that reason, I followed the very simple maths or very simple science of designing PCBs. I kept the ground on the bottom layer and other signals on the top layer. So if you see here, like the important signals or the signal which is coming from the controllers are on the top layer, and ground is available on the bottom layer. Why we need PCB like this? When signals start flowing in the traces, so it requires a written path for that. So if you follow this approach, this will allow you to reduce the EMI and EMC interference. You can avoid it easily. Later on, you may face some noise issues, but if you follow this technique, you will make your life easy. Okay, so in this way we have designed the tracks, and if you see, the track widths are about 0.3 mm, 0.5 mm, 1 mm and 2 mm. So if I show you here like this, V in is about 2 mm. Okay, and it is more than the suggestion, so you have to keep one thing, like if you know that your tracks are going to carry a large amount of current, make sure to do it more than sufficient. Like if you have space also and you have freedom also, so you can do that. Everything is already done, so now we will go for the final rating of our PCB, and we will ask ChatGPT to rate our PCB. Alright, so I'm not a huge fan of green color PCBs, I like black colors, so I will change the color of this PCB. Okay, I will keep it black, and for bottom also I will keep it black. Okay, then I will take a screenshot of it. I have added my image, and I will ask for rate my design on a scale of 10. Well, I have to add the bottom image also. So as of now, I can add one image at a time. So let's see for the rating. Okay. Evaluation criteria is something like this: component placement 10 out of 9, power and switching layout 10 out of 8.5, RS485 interface 10 out of 8. Okay, decoupling 9.5 out of 10, that is good. Thermal and ground strategy is 10 out of 8, and final rating is something about 8.8 out of 10. So this is good, I mean this is considerable. And let's add the bottom view also, and then we will ask it for review again, for overall review. Okay, so the final rating is about 9.1, which is good. I mean component placement is 9, power and signal is 8.5 out of 10, RS485 layout is about 8. Okay, decoupling capacitor 9.5, thermal and grounding 8, silk screen and levels 9.5, mechanical design is 9 out of 10. So overall we got 9.5, and I guess this is uh, quite good number, and out of 10 it is appreciated, and I really appreciate it, like the rating which ChatGPT given to us. And you can also write your rating in the comment box, so that I can get your evaluation, like how would you rate my design. In summary, it is saying that your board is well designed, professional and production ready, with only minor optimization possible for routing, copper pore and possibly thermal relief. You have shown excellent attention to the documentation, labeling and manufacturability. Okay, so I guess these are more than sufficient for designing a RS485 based switching circuit. So this was the video on KiCad plus ChatGPT. If you found this video helpful, make sure to hit the like button and subscribe the channel for more technical content.